Alrighty, hello and welcome back. Okay, let's smash through these and get to the end. The next set of questions are on substitution. So what you have to do for these is take these numbers that are at the top, so m equals 2. I'll just wait for it to focus. That's quite annoying. Hopefully I didn't do that in the last video because I actually would not have noticed. Focus video. What's this problem? Oh, there we go. Okay, so, alright, start again. It says m equals 2, n equals 6, p equals 4, and t equals negative 13. You have to substitute those numbers into these expressions to work out what the actual answer is. So the first one, for example, is 2 times m. Now, m is equal to 2, so you just say 2 times 2, which is 4. Pretty straightforward. Second one, 3 times n plus 1. Well, n equals 6. So 3 times 6 plus 1 equals 19. Next one here. Now 4 multiplied by m multiplied by p. So 4 times m equals 2, p equals 4. So 4 times 2 times 4, take away 6 multiplied by n, and n is 6, which gives us 32 subtract 36, which is negative 4. Cool, similar story here. We've got 2 and then it's n to the power 2. 2 multiplied by n to the power 2. Remember, n is 6. And that's squared. Subtract 20. 6 squared is 6 times 6, which is 36. 36 times 2 is 72. So we get 72 minus 20. I'll subtract 20, which is 52. Last one, t squared, which is negative 13 squared. Subtract 4 times m, which is 2, times p, which is 4. That, in the end, gives you 137, which worked out. Okay. Second one looks hard, but it's actually not so bad. You've got a formula here that you have to substitute certain values into. So if you, for this first one here, it says find t, correct 2 decimal places if L equals 1.24 and G equals 12. So we go 2 pi multiplied by the square root of L over G, but L in this case is 1.24. G is 12. If you put that into your calculator, you'll find that the answer is 2.02 seconds. Same for this one here. Find t, which is going to be the square root of L. In this case, is 2.15. G is 6. In your calculator, that gives you 3.76 seconds. Now, because you're multiplying something by pi, it's gonna be, it's likely at least to go on forever, depending on what sum you come up with, unless it happens to be something to do with the a circle. Anyway, when it says to 2 decimal places, you have to round it correctly, so be careful of that. Cool, moving on. Question number 5. Okay, so you've got... Yeah, it feels like the camera is lagging a little bit behind what I'm actually doing, so yeah, I do apologise if it, sometimes is slightly behind what I'm talking about, but I'll try and account for that. Anyway, y is equal to x.5. So you know from that you're... Well, just a quick reminder that I'll write over here Any straight line ever on a graph has the format y equals mx plus c. M is the gradient, c is the y intercept, and then y is the y coordinate and x is the x coordinate. The point being that this one here, it's in the form y equals mx plus c. Well, you just got an x, there's no number before it, so your gradient has to be 1. Intercept is 5. So you know that that first line is going to cross the axis here. Also remember that if your gradient is 1, that means that your rise over run is going to be 1. So for every 1 square that you go across horizontally, you'll go up 1 square vertically. So across 1, up 1, across 1, up 1, across 1, up 1. Anything with a gradient of 1 is going to have a, pretty, well, an exactly, I suppose, 45-degree line. Just going to be careful with drawing this freehand. Okay, so that's y equals x plus 5. This one here, y equals 2x, so gradient equals 2 plus 4, intercept has to be 4. Okay, so your intercept is going to be, I should use a different colour really, I don't ever have one lying around. I'll try this green whiteboard marker. Anyway, that seems to work pretty terribly, but that's okay. So that's your intercept, 4. Now if your gradient is 2, it means for every square that you go across, well, for every 1 square you go across, your line is going to go up by 2. So across 1, up 2, across 1, up 2. Again, gradient is given by rise over run. So if it's going up 2 and across 1, that's going to be 2 divided by 1, which gives you 2. So across 1 and up 2 if your gradient is 2. Connect those up. Okay, now remember when you're solving a pair of actually it wasn't too bad. When you're solving a pair of equations like that, you're looking for the place where they cross, which is here. So the point on the graph where both of these equations are true. So remember this first line will go on forever like that. I'll wait for the camera to catch up. This line here will go on forever like so, into infinity. But there's one spot on the graph where both of the equations are true, and that's this one just here, where x is equal to 1 and y is equal to 6. Now the way that you write that is to say 1, 6 like this. Whenever you see numbers in brackets like that and you're talking about graphs, the first number relates to the x coordinate and the second to the y. Cool. So that's how you do that. There should be a question about that on the test, but they're pretty easy really. You've just got to be comfortable with looking at an equation like this and saying, how do I know what gradient this is, and how do I know where it crosses the y-axis? Okay, next question. Solve the following algebraically by substitution. So you've got x plus y equals 3. But you also know that y is equal to x plus 1. So in this first equation here, you can just say x plus, and instead of this y that's here, you can just replace that with the x minus 1, or x subtract 1. Because you've got x plus y equals 3, but here you've got that y is equal to x minus 1. So we'll just check that right in there. So you've got x minus 1 instead of the y, which equals 3. Add all those together. Remember you don't have to expand the bracket because you're not multiplying, you're just adding, so the bracket can just disappear. So you end up with 2x equals, okay, so add 1 to each side to get rid of this negative 1. That'll disappear. We'll need a 4 over here. divide both sides by 2, you get x equals 2. Cool, so we've got our x coordinate, which is 2. Now we just need to substitute this value into one of these equations. We'll just pick this one here for convenience because it already says y equals, which is x minus 1. That's from here. Just wait for the pen to catch up. Yep. Y equals x minus 1. We've already worked out x, which is 2. 2 take away 1 is 1. So 2, 1, like this. That's your answer. Because x equals 2, y equals 1. They look hard, but they're not too bad. If you're solving by... Look, elimination isn't something we've done a huge amount on, so it's better to solve by substitution. That's the proper way to do it. That's the way that we've been doing it in class. So first thing you've got to do is rewrite one of these in terms of, you pick a variable, usually it's convenient to choose y, and rearrange the equation so that y equals something. So this one here, instead of having, x plus y equals 9, we'll take x away from both sides, and we'll say y equals 9 minus x. Cool. Alright, no one. So this one here, we've got x plus y equals... we could use this first one, that would be fine. So yeah, it's better we do that actually. We use the other one. So x minus y equals 1. And instead we write x minus 9 subtract 8, because it's taking away y, and we've already written down a different way to represent y, equals 1. Okay, so that if you combine these ones, you've got to be kind of careful here, because you've got a negative sign in front of this bracket which reduces the sign of everything in there. So instead of this negative x, you're going to have a if you take away this negative x, you'll end up with a positive x. So x and x is 2x. This negative applies to the 9, so yep, negative 9. To revert to, get rid of that, we'll have to add 9 to both sides. So we've got 2x equals 10. Divide both by 2, x equals 5. Substitute that back into one of the original ones. We'll go x plus y equals, where am I looking, 9. 5 plus y equals 9, so y must equal 4. So your answer, again, writing it in the way that we did before, we go x equals 5, so that's first in the bracket, y equals 4, that's second. Like that. Cool. Alright, last question. Ultimate hooray. Okay, form pairs of simultaneous equations and hence solve the following problem. Okay, so you've got two numbers, and it says let the numbers be x and y. Now the sum of these two numbers is 25. Okay, so x and y is 25. Cool. We can rewrite that in terms of y by saying y equals 25 minus x. Alright, the difference is 11. So x minus y equals 11. Alright, so we do the same trick before. We'll go x minus what we've written for y, which is 25 subtract x, equals, sorry, lost track for a sec there, equals 11. X subtract negative x is 2x. No, you'll end up with this negative 25 as well, so add 25 to both sides to make this one disappear, which will give you 36. Divide both of them by 2, x equals 18. So that's your first part of your bracket there. Alright, substitute that back into one of these. Let's say y equals 25 minus x. We've worked x out. Y equals 25 subtract 18, which is 7. So y equals 7. That's the second part of everything there. Again, your answer can just be at the very end, x equals 18, y equals 7, or you can write it in the bracket form like that. Look, either way, I'm going to know what you're talking about. Okay, that's it. Thanks a lot.